Alright guys, so to start with the next tutorial of finite element analysis with assembly. So now we are in the assembly template windows. So just click on product one and start to insert the part that we have. It should be not the new part. So come back here, product, insert existing component. I will select a stiffener and a bracket together and then click open. Okay, so there's some incident report. It means that they are being in one session. There are two parts. It doesn't matter. So what we need to do, if we want to separate this, we can move it, or in this case I want to use explode function and just click OK because the product has been selected. And yeah, the warning is you want to accept this and click show yes. Okay, so these are the two parts that you have. Okay, so next I will try to connect this part on these surfaces, and I will make sure that this part will be resting on the surface, and while the top one will be resting on the top surface. Okay, so to do that we need to move this thing, the stiffener towards the surface. So I will start with maybe contact constraint first, and I will make sure that this surface here is selected. This surface is selected first, and then the next one will be this surface. If I click this update button, update all button, or Control U as the shortcut, I should expect that this bottom surface of this stiffener will turn and attach to this top surface of our bracket. It doesn't do that, so I'll just Control Z. I think because of this is the first element that is being exported in our product. Doesn't matter, so I will start with taking this surface first. Right, so this surface will be the first, and then the second surface will be this surface, and I click OK. I think this one is good. Next one will be to turn this surface upside down. Okay, so we have the stiffener in the correct orientation. Okay, right, next will be to make sure that this stiffener is in the middle of this bracket. So firstly I will need to know what's the distance, so I will measure, find this ruler. So I will click on the surface and this surface also. So you should have the distance between these two lines. It's about 10 millimeter. So it means that it should be in the middle of about 5. Next, but I also have a thickness of this stiffener, so I think I measure this stiffener first. So it has a thickness of 0.5 millimeter. So it means mathematically I will need to have this half, so 0.25. So it means that the distance between this line and this surface would be 4.5. So with that calculation, I start by using offset constraint, clicking on this surface and then clicking on this line. I will change it to 4.5 millimeter and click update all. That's it. I think should be in the same distance. If not, I will check first. So that is 4.5. Okay, that's not correct. This is 4.5, this is 5, so it should be 4.75. Alright, so if it is correct or not, let's just look at it. Then we have the same length for both sides. So it's confirmed that it's already in the middle of the bracket. Okay, so I finished assemble my part. I will then firstly, before I transfer to GSA, General Structural Analysis, I think I want to save the time by assigning the material first here. Right, so I will take the same material, aluminium, and click OK, or click apply material. And then for the next part also, I will choose the part body and assign the same material. Click OK. So want to check whether it's already assigned the same material. Okay, so the material has been assigned. You can close the tree here, and we can now move to the GSA. So click Start, Analysis Simulation, and Generative Structural Analysis. Click on it. Alright, so we are here. So the warning is no more because I already assigned the material. So we'll choose Static Analysis, of course. And yeah, we just need to repeat the process that we have seen in the previous video. So firstly, I would like to restrain these two holes by using clamps. So this is the boundary condition. The next one, yeah, we cannot finish with just assigning the force here, distribute the force. I want to use the same value. Click OK. It's not finished just yet. You cannot run the simulation yet. So what we need to do, because these two elements are not connected, if I run the simulation, I will have the same effect without using the stiffener. I mean that without proper connecting between these two bodies, you won't get the effect that we need. So if you look at the previous analysis, if you look at this previous analysis, okay, the data is already gone, but it's okay, I can run it back. So for comparison, if I look at the displacement, for example, if I change to average ISO, so we have 22.6 millimeter maximum displacement of this top part, and it's happening on this edge. So I would like to see if I have stiffener here, it should not exceed 22.6 millimeter at this edge. But to make that happen, I have to connect these two before we run the simulation. Okay, so to do that, we have to select here, this one. We have to find this toolbar. It's analysis support, and another toolbar that we need is this one. I call it as connection properties. So this one, you will see what happened when I assign it. So what type of analysis support we need to choose for now, because these two parts is being separated by lines, so I will choose line. So this one, line analysis connection. So there are two types, one with one part or line connection. So I choose line analysis connection, whereby you have two components to be selected. So the name of the analysis is like this. So the first component to be selected will be yeah, this one, and the second component will be the stiffener. Okay, and then we have to define the lines. So the line would be this edge, each edge. Okay, and then click OK. So we should have 1, 2, 3, 4 main lines. You can also select this small edge here and also the bottom edge. You can do that. So let us finish each lines first. So I will choose again this part body, and then the second component will be this part body, and the lines will be this line. Click OK. So you have to be careful when you're selecting the lines. Again, line analysis connection. The first component, make sure that it is blue color, means that it is active. So this is the first component, and then click the second component, and then only you click the stiffener. And then for the line, you have to click on the selection here, and only you can select the line. So because this is not clearly seen, I just click this edge first, So maybe we can just neglect this line, and then again for the last line, so this is the first component, and the second component will be the stiffener, and the lines will be this edge. Click OK. Click OK. So I will just leave with these 4 lines first, because I don't think this is critical. Okay, what I did is actually showing you guys that this is how we at the manufacturing process would like to connect between these 2 parts. So normally we just weld. If these are 2 metals, so we just weld it. If for aluminium, we also have aluminium welding, MIG, for example. So in this case, we'll simulate as if it is being welded together. So for the analysis support, we have finished selecting the line analysis connection. So what will happen when I finish defining the lines, so you can look at the properties. You will have this 3D property here. This one, the analysis connection manager. I just open all the trees first. You can see, so all these 4 lines has been defined, is then located here. But of course, you see there's this update all symbol there. It means that it is not yet finished. So what we have to do now, we need to define the connection properties. So we have so many things here. So the one that we want to select will be sim welding, because these are lines and not a point, so we need to define as sim welding. Okay, sim welding means it's a line. Okay, so the support will be the line here, number 2. So we have to select one by one. So I start with this one again, the next one. So you see, when you select the correct line, the correct support line, there will be this symbol, sim welding symbol. So next will be this line, and last one will be this line. So what happened after I selected it? You see there is a new 3D properties being added here, and also the nodes and element. Okay, with that, it's already finished, but there's still update symbol there. It's mean that it's not yet finished, because we haven't simulate the compute the simulation. So if I look at the our static case analysis, I think we are in the correct direction. So we can just compute the simulation. So just the same as before, I don't change the mesh size and everything. I'll just proceed with the computation. Just click the compute, and we can click all. We have no specific case, so just click OK down there, and we wait whether there is a metric factorization. If there is no such warning, then our calculation is success. Yeah, it's a success. It is a success. So if you can see, if I click the deformation, the deformation is still happening, but that we need to verify the value. So let's just look at the displacement. So you can already see the maximum displacement is very much less than 20 millimeter. So you see the spot is actually help distributing the force. Okay, so by using the line connection and welding properties, you see that as if these 2 elements are a solid. So that's the way we want to simulate a proper properly for assembly. So in this example, I use line properties, line connection, and sim welding on the line. So if you want to see what happened if I cut these 2 into its cross section, you can see that the nodes and elements are connected properly. So if I change the direction to the back, so if I move this thing, you can see the T-joint down here doesn't change. So it means that the connections are proper. Okay, So that's all for our simulation now. The last thing that we can also look from this simulation is creating the report. So the report that can be seen is this one, generate report, analysis result. So you can click on this Affini with generate report, Affini solver log, and if I click OK, the report will be written there. It doesn't matter. And then next will be click on the generate report, click on the static case, and click on the click on the browser, and this is the HTML report of your simulation. So you see, this is the original boundary condition, the original parts with boundary condition, and the data of structure computation, the nodes number, the number of elements, the degree of freedom, and the string computation, and other type of data you can read through. So this is the static case solution. Deformation, form is a stress. So you see, the stress are still at the hole, because this is normal. For element with holes, the concentrated force will be occurring at the edge. Alright, so come back to the drawing. You can try on your own. If you don't have this stiffener connected properly, and then you run the simulation, you will see that your result should be the same as if you are doing the analysis from the previous video. Okay, that's all from me. Bye bye.